Hi, everyone. Good morning, good afternoon, good evening. Welcome to the YugabyteDB Friday Tech Talks series for engineers, from engineers. Mentioned that today is apparently our 40th episode of the series that we started at the beginning of this year. And it's my pleasure to welcome Srinivasa Vasu on today's talk. Srinivas, would love for you to introduce yourself, what you do at Yugabyte, and then you could also get started with the topic.
Yeah, thanks for having me, Kannan. Hi, everyone. Good to be here. I'm Srini, based out of Chennai, India, field engineer. So we work closely with the community and customers, try our best making sure that they are successful in their adoption and cloud transformation journey. And today's topic is on deploying multi-region YugabyteDB on Google's managed Kubernetes distribution, GKE. All right, let's get started. This is the flow of the talk. We look at what are the key business drivers. Why would organizations look at multi-region deployment? What are the influencing factors? And then obviously, we look at it from the perspective of different personas of the organization. Is it a single persona's concern, or is it a collective concerns that everyone is really looking at multi-region deployment? And then we look at why Kubernetes in particular, why organizations more and more likely to use Kubernetes as the de facto runtime engine, not only to run stateless applications, but also to run distributed stateful applications such as YugabyteDB. And then we look at we'll look at some of the advantages, generally the influencing factors. Why would organizations look at Kubernetes as the de facto runtime again? And then some of the challenges to watch out for, right? So, I mean, every technology comes with its own set of merits and demerits, right? So, especially from a multi-region standpoint, what are the challenges that we have to deal with? And finally, we look at what are the various deployment options that we have. And then we'll have a sneak peek of one of the work in progress standards by the upstream Kubernetes community. All right. More on the business drivers, right? So we have listed out some of the key business drivers. This is not all of it, but we thought that just to bring in the perspective of the different personas of an organization, right? So multi-region deployment is not a single persona's concern, right? So every persona in the organization is looking at multi-region in their own way for good reasons, right? For example, if you look at it from the perspective of app dev, right? So as far as application developers are concerned, user experience is paramount. Yes, user experience is a collective responsibility of the organization. Everyone is striving hard to give a better user experience for the end customers, right? But the onus lies with the application developers, right? So if you look at the application architecture in general, right? Thanks to the advent of cloud, the infrastructure is elastically scalable, which has paved way to the natural transformation of having a scalable runtime, right? So if your user base is globally distributed and you can have an application architecture that is horizontally scalable, you have the leverage and flexibility to have the applications deployed as close as possible to your user base. But if you look at the architecture on the left side, rather the back of the arrow mark, right? This is the architecture we largely see today, right? The infrastructure is horizontally scalable. The runtime is horizontally scalable. The apps are scalable, but the data is still confined to a single node or single region, right? So what good does an infinitely scalable infra runtime brings in? The data is still confined to a single region, right? So we end up not having a good user experience, right? So if the user is far located and still you need to serve the data off of the single node data region, the experience is not going to be good, right? So that's why app devs are more inclined towards a scalable data platform, right? So we want the data layer to be in line with the scalable infrastructure as well as the application data, align more closely towards the application layer so that you'd be able to serve the request closer to the user base and so on and so forth, right? Moving on to a different persona, more from an operations standpoint. This persona is identified in multiple ways, depending on how the organization itself is aligned, structured, or whatnot, right? So DevOps, Cloud Ops, or SREs, generally the operations people, right? As far as operations engineers are concerned, their prime responsibility is like the service can never be down. It needs to be always highly available, up and running, right? So if you are running and operating critical business customer-facing applications, you can't have the service down even for a few seconds, right? So if it's down even for a few seconds, then you would become a sensation in the social media, right? So as far as operation teams are concerned, the service level objectives need to be met at any cost, right? Yes, cloud gives us the flexibility in a region. You have multiple fault domains, you can deploy applications across multiple availability zones in a region. But in the past, we have seen an entire region going down for a couple of hours, sometimes for days and whatnot, right? So it is a rarity, but we can't rule that out, right? It had happened in the past, most likely it may happen in future as well. So that's one of the compelling reasons why ops teams are leaning towards a multi-region deployment of their service. So that depending on their error budget, as you can see, like any distributed system, if you want to withstand a single fault domain failure, so there is a formula that underpins it, right? So if n being the fault domain, if you want to withstand one fault domain failure, then you need to operate at least 3 fault domains, right? And if you want to withstand 2, then 2 into 2, 5 fault domains to be in place, right? So this gives them the flexibility so that they will be able to meet their decided SLOs in terms of whether 3 nines or 5 nines or whatever it is. They will be able to fulfill all those requirements. And that's one of the reasons why ops are more inclined towards a multi-region deployment. But more from in this case, I've depicted it, to keep it simple, there's a stretched deployment across 3 fault domains with more from a representation standpoint. I've represented 1 fault domain or 1 node per fault domain or whatnot, but based on your requirements, you can have more fault domains and more nodes in place and so on and so forth, right? And moving on to the security ops, right? So multi-region is equally important for them as well, to comply with data, locality, regulatory and compliance requirements, right? This is a slightly complex architecture compared to the previous one. So this has got, so in your applications, you might have requirements where the data would be geo-distributed. You might have geo-partition data, more from a data governance standpoint. Data that originates in a region should stay within the region. If that's been the case, the availability requirements are still important, right? The resilience need to be factored in, right? So again, within a region, you have to factor in replication factor, multiple copies of the data. And that's why you see multiple fault domains in this case, right? And geo-partition or geo-local data, data that is living only in a qualified region still needs to be replicated. We still have to ensure that the availability factors are taken care of, right? So it's a collective responsibility, and every persona in the organization is more and more looking at a multi-region deployment. And this is something that we have started to see a lot with our customers as well. And moving on, now the obvious question is, we have been seeing a lot of traction with Kubernetes in general as a runtime platform. More and more we see cloud-native deployments running on Kubernetes. The Kubernetes as a runtime has come a long way, right? What started as a runtime to run and manage your stateless applications, the platform has matured a lot. We have been seeing a lot of cloud-native stateful applications being run on top of Kubernetes, right? Just before we move on, for those of you who have been hearing about Kubernetes for the very first time, think of Kubernetes as a cloud operating system, right? So cloud here doesn't mean public cloud. Anything that is elastically scalable, right? So when you deploy an application, the operating system schedules your application, allocates memory, CPU, and then it lets your application interacts with networking, storage, and whatnot, right? Kubernetes does the same thing for your applications in a distributed fashion at scale, right? Think of it that way, right? When it comes to advantages, what's the hype cycle around Kubernetes, right? Why all of a sudden all the organizations are looking at Kubernetes, right? In essence, Kubernetes is an orchestration engine, basically to manage a fleet of applications, in the context of pods at scale, it comes with an intelligent scheduler as well. Basically, it looks at your resource utilization, and then it figures out the best placement for your application, right? So a lot of goodness are built into the runtime itself. And cloud portability is one of the promises of Kubernetes, right? Basically, Kubernetes is an abstraction layer, hides the infrastructure complexity. The application is totally unaware of where is it running, right? Whether it's running in on-premise or whether it's running on one of the public cloud providers, that is totally transparent to the application layer, right? But more from a portability standpoint, we still have to factor in some of the other things, like networking and so on and so forth. But in general, it offers you the portability, right? And resource scaling, that's one of the unique value propositions of Kubernetes as well. You'll be able to easily scale out, scale up on demand, or scale down based on the requirement, right? Self-healing is one of the aspects, which is quite different from a virtual machine-based infrastructure, right? So, and virtual machines, you need that. Either if the virtual service provider handles it, then you'll be able to closely monitor VM failures and what needs to be, what actions to be taken, and so on and so forth. Whereas with runtime like Kubernetes, it comes out of the box, right? So basically, if your application pod crashes for some reason, or if the node crashes for some reason, and the scheduler ensures that your applications get placed in the other surviving nodes in the cluster, as long as the headroom is available, does its best in terms of moving your workloads across automatically, right? And then it allows you to, I mean, it transparently orchestrates storage, networking, other things as well. So that becomes pretty easy when you run it on top of Kubernetes, right? And one of the important factors, more from a cloud native microservices architecture standpoint, is the service discovery. As you can imagine, in a microservices based architecture, your business domain is broken down into multiple services where each services have to communicate with each other, right? So the service discovery is essential, right? The whereabouts of all the services, part of the business transaction, need to be identified. They should be able to interact with each other with a stable identifier, right? So which is something that Kubernetes provides at cluster level, so that services can communicate with each other, right? And so we spoke about a lot of merits, but each technology comes with its own challenges as well, especially with from the perspective of multi-cluster, right? Whatever we saw so far, it's all limited to a single cluster, right? So when it comes to networking multiple Kubernetes cluster, that's where things get complicated, right? And it's not an easy affair in terms of networking multiple Kubernetes clusters, that too across multiple fault domains or multiple different regions. You have to do a lot of heavy lifting. There is no defined standard per se. But the upstream Kubernetes team has published a work in progress standard, which we look at it in the subsequent slide, right? And the operational maturity is also very important, right? So because Kubernetes itself is complex, it adds one additional layer on top of your existing stack. And it comes with a lot of moving components as well, right? So if we don't have the right skill sets and SMEs to troubleshoot something goes wrong in production, then that becomes extremely difficult to run and operate your application. So, right, these are some of the things that we need to watch out for.
So, Srini,
yep.
One question on the previous slide. The reason you mention multi-cluster Kubernetes is that because we are talking about multi-region Yugabyte deployments on Kubernetes, and is that because Kubernetes on its own, a Kubernetes cluster is limited to being in a single region?
Correct. That's right. That's right, Kannan. All the goodness of Kubernetes is still limited to a cluster. There are a lot of initiatives, work in progress initiatives to seamlessly manage a kind of federating multiple clusters together. And we are going to look at one of the standards, right? So that tries to simplify networking multiple Kubernetes clusters, right? As you rightly said, in this case, we are talking about multi-region deployment of YugabyteDB, more of a stretched deployment of YugabyteDB on top of multiple region local clusters. So these YugabyteDB instances have to talk to each other, right? So the service discovery needs to be enabled across multiple region local Kubernetes clusters.
Got it. And second question, Srini, is like this talk was around GKE, so that obviously raises the question like is itself across different cloud providers. Are there lots of small differences? I mean, how do you categorize the difference? Like how much of this talk, for example, would be applicable for say Azure's or Amazon's Kubernetes environment?
Correct. The standard itself is still in alpha beta stage, Kannan. So the implementation is up to the Kubernetes distribution vendor, right? So GKE has their own implementation that is available that we can test it out today, and EKS to an extent. I believe that all the other Kubernetes distribution will have the MCS API or whatever the standard that we are going to look at it as part of their distribution itself in the future. So going forward, we'll find it similar across most of the distribution. Similar to how we deploy an application to a single cluster, we expect the same kind of behavior across multiple clusters irrespective of the distribution that we use.
Got it. And the standard, the evolving standard you're talking about specifically applies to this networking across multi-cluster.
Correct.
Okay. Yeah. Thank you.
That's one of the factors. Great. Yeah. And yeah, it's a nice segue to the standard. So there are multiple ways that we can do networking across multiple Kubernetes clusters. So I'm not going to get into the details of all the options. You can refer to the link. We have published the steps in terms of how to get all those. I mean, if at all DNS is your preferred option, I mean, you can go through the steps to get it activated, right? So, but one of the standards, what I'm going to cover today is more on MCS. In short, it's called Multi-Cluster Services API. So this is a Kubernetes, this is part of Kubernetes enhancement proposal championed by the upstream Kubernetes SIG special interest group to facilitate networking across multiple Kubernetes clusters in a more Kubernetes native form, right? So with known primitives of Kubernetes, how we can easily set up networking across multiple Kubernetes clusters, right? Before getting into the MCS API itself, let's understand some of the basics in terms of how we deploy an application in Kubernetes, right? So in order to deploy an application, you have to bring in a couple of YAML manifests, right? So you have to define a deployment manifest, and then you have to add a service manifest to it to give a DNS name to your service and so on and so forth, right? Typically, the definition would look like this, right? So you define a name to your service, and then you deploy your service to a specific namespace, more of a project. Think of it like a project. And then you tell which are all the backing instances, right? So this DNS is backing what are the application instances, right? Basically, you select it with a label, right? So if your application is having that label, then the service would appropriately filter out all the matching applications, right? And the way to invoke the service, this is again a Kubernetes standard. The service name followed by namespace name followed by service.cluster.local. Cluster.local is the default domain name. Use the domain name to invoke it, right? So when you use the service, a typical normal service will give you the whereabouts of all the backing pods, application pods, right? If you have 3 instances, then what it does is it load balance across one of the running instances. That's what a typical service does, right? The load balancing and discovery part is built into it. Or the consumer, as far as the consumer application is concerned, it just has to invoke that. So it has to invoke that producer service using this DNS name, and then Kubernetes does the rest, right? So it load balances your request across one of the instances. But when it comes to stateful applications, such as YugabyteDB, right? Each instance of the service should know about the whereabouts of the other services, other instances in the application, right? So we can't rely on the DNS alone. So that's where Kubernetes provides another manifest called headless service. The difference between a normal service and a headless service is, in the case of headless service, well, it will not return any virtual IP per se. So in normal service, it returns a virtual IP and then it load balances to one of the available instances, right? Whereas in the case of headless service, it does not give you any virtual IP. Rather, when you query based on the DNS name, it gives you all the IPs, right? So if you have 3 instances, it gives you the IPs of all the 3 instances. If you have 5, you'll get 5 IPs. Then you decide what you want to do with all those individual instances, right? So that's what important more from a stateful application standpoint, right? So we have to send instance to instance communication is required. Instances would exchange heartbeat information, data, and so on and so forth, right? Typically, the format is like hostname.service.namespace.service.cluster local, and the host name is each instance gets assigned with an ordinal, right? So that's the stable identifier that you get with a stateful deployment, right? So if you create a stateful application with 3 instances, you'll get it as YBDB-012, right? If it is 10, then the ordinals would range from 0 to 9, and so on and so on, right? So that's the format, right? Multi-cluster services API, it leverages the same thing, right? We are familiar with the service manifest and headless service and so on and so forth, right? The first and foremost thing what we need to do in order to enable multi-cluster API is to bring in, which are the clusters where we want to enable the networking. We have to bring in all those clusters under one logical group called cluster set. It's more about activating MCS API service in all these clusters, right? So if you want to network between 2 clusters, you want to network between 3 or 5 clusters, then you have to bring in all those 5 clusters under a fleet so that the MCS API gets, the infrastructure itself gets installed in all the clusters. Basically, it installs a bunch of pods, again, controllers, DNS service importers and exporters to facilitate the multi-cluster service discovery itself, right? So you bring in multiple clusters into cluster set. And then let's say from a producer standpoint, imagine you have a service named YPDB. It is same as the service that we saw in the previous slide, right? If you want to export the service to be made discoverable by other clusters in the cluster set, all you need to do is to create a CRD. In Kubernetes parlance, we call it as custom resource definition. You'll create the service export object, right? It is pretty self-explanatory, right? I want to export this service so that rest of the clusters that are part of the cluster set will be able to discover this service automatically, right? So once you export the service, what MCS controller does is it automatically identifies that events and it imports that service in other clusters that are part of the cluster group itself, right? So that's how the export and import works. And there is a little nuance in terms of how you would create the DNS here. There is one additional parameter here. In addition to host name, we have to include cluster ID as well. The reason why we need to include cluster ID is, imagine you are exporting same service from 2 different clusters, right? Then the identifier would remain the same if you don't include the cluster ID, right? But we need to exactly differentiate service 1 is coming from YBC1, service 2 is coming from YBC2 or whatnot, right? That's the reason we need to include this additional parameter. Cluster ID is more of an unique identifier for your cluster. So hostname.clusterid.service.namespace.clusterset.local. So that's the default domain name for multi-cluster services, right? Cluster.local is limited to a single cluster. Clusterset.local is more of multi-cluster services that you want to be, discoverable across multiple clusters that are part of the cluster set. All right. So in the interest of time, I've already created the cluster. What we are going to look at it in a real world scenario, we may not create a stretched cluster across the globe, but you can think of it that way, right? Probably you would create multi-region clusters in Europe region or Europe, Asia or whatnot, right? But in this case, I've created 3 GKE clusters, one in Asia, one in Europe, and one in US Central, right? And I've already brought in these clusters as part of a cluster set, a single fleet, and then I've already activated the MCS API, right? And on top of it, we have deployed a stretched YugabyteDB cluster. It's a single YugabyteDB cluster stretched across 3 different regions, right? Let's look at the cluster itself. Hope everyone is able to see my terminal window.
Yes, Srini.
Font size, okay.
Yeah.
All right. Before moving on, let's quickly look at the GKE console itself. So as you can see, we have 3 clusters, 3 GKE clusters, and what it does is basically it has to multi-cluster services API. It has to set up the hosted zone infrastructure for all these clusters, right? Because it sets up a DNS which is accessible across all the clusters. So what it does is once you activate, once you export your service from one of the clusters in the cluster set, it goes and sets up an internal hosted zone, right? So in the internal hosted zone, what happens is from YugabyteDB standpoint, we have master and T server process, right? For each individual instance, it sets up this DNS, and this DNS again gets imported into all the clusters as well. That's how using this DNS, all these instances can communicate with each other, right? So that's what MCS does. So generally, when you set it up for the very fast time, it takes some time because setting up the DNS and all take roughly 2 to 4 minutes. But once the infrastructure in place, it'd be able to use this instances across multiple clusters. All right. Okay, as I said, we have 3 contexts, 3 different Kubernetes clusters, one in AP South, one in US, and one in US Central, right? And if we get into AP South itself, if I get into the namespaces, I have a namespace defined AP South. That's where I've defined, install a single instance of YB master and T server, right? So this is one of the fault domains where we are running YB master and T server. And if you look at the service export object itself, sorry. So we have YB masters and YB T servers service export defined there. The definition itself is very straightforward, right? So it carries the name of the service. The name of the service here is YB server, YB T service, and it runs in this namespace AP South one. I want this service to be exported so that other clusters in the cluster set can discover this service, right? And if I go back and then look at the service imports in this cluster, right? So I see service imports from multiple namespaces because this is understandable, right? So we have 3 Kubernetes clusters. AP South namespace, South Kubernetes cluster, the namespace is AP South. And then similarly, we have U West and U West cluster and US Central and US Central cluster, right? So if I get into U West, if I get into EU West, I'll see the service definition. And that is also pretty straightforward, right? So the service name is YB Masters, which has been exported in EU West cluster, and that's been imported to AP South cluster, comes from the namespace EU West one, and it is part of this cluster, right? So the cluster membership is also there, right? So that's how you get to know, okay, this instance is running in this cluster, so that YB master or T server instance in the AP South will be able to communicate with other instances in the rest of the Kubernetes cluster, right? So that's how multi-cluster services work. I mean, in the sense, activating an MCS API, you have to go through a couple of steps. You have to activate a couple of APIs, and then you have to bring in these clusters as part of a fleet. And once you set up all the necessary infrastructure in place, then it works like a breeze. I mean, like how typically Kubernetes works, right?
Srini, like in your example, you have 3 nodes, 1 in each region. But let's say this was a 12-node cluster where there were 4 nodes in each region. Then for communication that happens between the nodes within a region, let's say, or whatever be the case, like maybe there's a request that needs to be forwarded to another node. Do we use the same long name, global name, or it bypasses that and it's a two part? Like,
yeah, we can use the same name, Kannan. So there are 2 ways that we can get it done. So with YugabyteDB, there's something called use private IP, where you can specify, do you want to use the internal IP for regional communication and then external IP for cross-region communication? We can do that as well. Otherwise, we can always use the long name itself, right? I mean, the long name is something that we don't need to code it. It gets resolved automatically, Kannan. So only the initial parts need to be defined. The cluster set.local is the default domain name. So if you look at our Helm distribution, it already supports MCS API for GKE. So I can show that part as well quickly. So So in the Helm distribution package, we just have to mention these two flags. So this installation needs to enable multi-cluster services. So create service exports automatically for all the YB instances that we deploy to the cluster. And then you just have to specify the cluster ID, right? So basically you have three clusters, right? So YB, AP South 1, EU West. And once you define all these things, then the necessary artifacts and all those things are automatically created by our package distribution itself.
Got it. One reason I asked the question was, if I remembered correctly, like cloud vendors charge for inter-region network costs differently than private. And whether by not using this private IP, does it end up by going through the longer name, do you end up paying an inter-region network cost even though your networking is between regions in some cases?
Correct. We would still end up paying it because it leaves the region though. Yeah.
Got it. Got it. No, no, I'm talking about the case where the communication is happening between two nodes in the same region. But
correct. Yeah.
But instead of using the private IP concept, if they're using the same name as the to talk the fully specified multi-cloud name to talk between nodes within the same region.
Got it. Got it. I got your question. Within the region, it's internal only, Kannan, though the cluster set, because when it sets up everything, the IP is going to resolve to the subnet range that you've defined, right? So it knows the subnet for the local cluster. So that communication is anyway going to be local. Because in this case, you get the whereabouts of the IP itself, right? The DNS resolves on IP and the networking is going to happen based on that. Yeah. All right. Yeah, just quickly get into the, just to show you the embedded Yugabyte UI. You can see the same thing here. So 3 instances of replication factor is 3. And if you look at the config information itself, so it's a stretched cluster across 3 different regions. And then replica of 3 with 1 replication factor per fault domain. And rest of the things would remain the same, right? It's no different. And in the earlier YFTT talks, we spoke about how to create partition, geo partition and so on and so forth. You can apply all those things here as well, right? And this being a cluster with a replication factor of 3, at any given point of time, the cluster would continue to operate even if you lose one of the regions. Yeah, that's pretty much I wanted to cover.
Yeah, thank you so much. We are on time. And let me just make sure if there's any more pending questions on the channel. Yeah. So yeah, I think just to recap a few things, there's a lot of interest in running stateful workloads on Kubernetes because of the portability. Srini alluded to some of the challenges and some of the developing standards here. I think in this particular case with multi, it was pretty, some of the building blocks that Google has made it pretty easy to get this going. And then just to recap, you also talked about the relevance of multi-region deployments to different personas, how app developers can take this into the equation to bring data closer to how the infra and ops teams can build highly resilient deployments that are resilient to data center failures, and how security teams, for example, can accomplish their compliance requirements of keeping data, region local. So a lot of topologies possible, and and it goes with some of the same trade-offs. How far apart the regions that you pick, it affects your latencies. So, but the cool thing is cloud vendors are now offering so many locations, so many regions. It doesn't have to be a cross-continent deployment. You can have inter-region deployment where your regions are hundreds of miles apart, still give you DR safety. So it's a fascinating space to see how the progress is happening on a variety of fronts. And thank you everybody for joining. Thank you, Srini, for a wonderful talk. And we'll see you next week. But Srini, over to you for closing comments.
Yeah, thanks once again, Kannan, for having me. Yeah, folks, please try out MCS API. Our Helm package already supports it. So if you have any requirements or thoughts or ideas that you would like to share with us, please feel free to drop into our community Slack channel. And you can join our YFTT channel as well, so we can discuss if at all if you have any questions or clarifications there. Thank you so much.
Yeah, I hadn't seen this QR code before. Nice. Does that take us? Where does that take?
It takes us to YFTT YouTube.
Oh, okay, got it. Thank you. Thank you, Srini. Bye, everyone. See you next week.